Lesson 5-2, solving equations with variables on both sides. A while back, we learned how to solve multi-step equations, such as 5x minus 3 equals 15, right? And 5x minus 3 equals, let's say, 12. And we learned how to work backwards by using inverse operations in order to isolate the variable. So just to refresh our memories, how would we go about solving an equation like this? Well, the first step we would probably take is to undo subtraction by 3. And to undo subtraction by 3, we'll do the opposite of taking away 3, right? We'll add 3 to each side. Right, if I add 3 to the left side, I have to balance my equation out by doing the exact same thing on the right side. And that is probably the most important thing you need to remember about solving any equation, whether it's a simple one-step equation or a complicated multi-step equation. Whatever you do to one side of the equation, you must do to the other side. As long as you keep that in mind and don't forget that you have to keep your equations balanced, you really can't go wrong. Okay, so on the left-hand side, negative 3 and positive 3 is a zero pair, so we can cancel those out. We are left with 5x equals 12 plus 3 is 15. The opposite of multiplying by 5 is dividing by 5, so we'll divide by 5 on each side. 5 divided by 5 leaves me with 1, right? So I have x on my left-hand side equals 15 divided by 5 is 3. So my solution is x equals 3. And of course, you should take your solution and plug it back into your original equation to check your work. Now, what if I gave you a slightly different example that looks like this? Let's see, 5x minus 4 equals 7x. Now, right off the bat, you might notice something a little different about this equation, and that's the fact that I have like terms on the left side of the equation as well as the right side of the equation, right? Like terms, once again, are terms that have the same variable. And in previous examples, all of our like terms were on one side of the equation. But in this case, I have a 5x on the left-hand side of the equation, and I have a 7x on the right-hand side of the equation. And that really is the only thing that's different about these types of equations. As far as solving them, we're still going to be using the same inverse operation. The first step we need to take is to figure out how we can get all of these terms on the same side. And I have a couple of options here. Okay, I can either choose to bring this 5x over to the right-hand side of this equation, or I can choose to bring this 7x over to the left-hand side of the equation. It really doesn't matter which you choose because you will ultimately get the same answer, right? As long as you're doing the same thing to both sides of the equation. In this example, let's eliminate the 5x on the left-hand side. So how do I get rid of this positive 5x? Well, we're going to use an inverse operation, right? What's the opposite of adding 5x? That would be taking away 5x, right? And if I take away 5x here, I have to take away 5x here. So what is 5x minus 5x? Well, that's 0, right? Because any number minus itself is 0. So 5x minus 5x is 0. We can cancel those out. We are left with negative 4 equals, on the right-hand side, I have 7x minus 5x, which is 2x. And our last step, of course, would be to divide by 2 on each side. And we are left with x equals negative 4 divided by 2 is negative 2. So we have x equals negative 2 as our solution, and we will check our work by plugging negative 2, our solution, back into the original equation. 5 times negative 2 minus 4 should equal 7x. Let's see if we're correct. Oops, it should equal 7 times negative 2, right? Because x is negative 2. 5 times negative 2 is negative 10, minus 4 equals 7 times negative 2 is negative 14. Negative 10 minus 4 is negative 14. And negative 14 equals negative 14. Our solution does indeed check out. So let's try a couple more. After we do a few more, I think you're going to see that these really aren't so bad. Alright, let's consider the equation 6x, negative 6x, plus 3 equals positive 6x. So once again, we have like terms on both sides of our equation, right? We have a negative 6x here, and we have a positive 6x on the right side. Before we can isolate the variable, we have to get these like terms over to the same side of the equation. Now, whether you choose to bring the negative 6x over to the right-hand side or the positive 6x over to the left-hand side is up to you. Once again, as long as you're doing the same thing to both sides of the equation, you are going to get the same answer in the end. Okay, let's get rid of the negative 6x on the left-hand side. So what is the opposite of taking away 6x? Well, that would be adding 6x to each side, right? Remember, my goal is to make this 0, okay? In order to eliminate the negative 6x, I have to add 6x, okay? Because now these cancel out. I'm left with positive 3 equals, well, what is 6x plus 6x? That's 12x. And our last step would be to do the inverse of multiplication, right? Because on the right-hand side, I'm multiplying 12 times x. The opposite of multiplying by 12 would be dividing by 12 on each side. 12 divided by 12 is 1. So on the right-hand side, I'm left with x. And on the left-hand side, I'm left with 3 divided by 12, which, if I simplified that, I would get the fraction 1/4. And of course, you would then take this solution, 1/4, and plug it back into your original equation to check your work. Alright, let's try one more. Let's see. Okay, this equation is a bit more involved, but let's break it down step by step. We have negative 3x plus 4 minus x equals 12 minus 2x. Now, the first thing you might notice is that on the left side of our equation, right, on this side of our equation, we have two like terms that we can combine, right? We have a negative 3x, and we have a minus 1x. So before we do anything else, it would be a good idea to combine these two like terms. So what is negative 3x minus 1x? Well, that's simply negative 4x, right? Because negative 3 minus 1 is negative 4. So we have a negative 4x plus 4 equals 12 minus 2x. Okay, now we have a negative 4x on the left side of our equation, and we have a minus 2x on the right side of our equation. Okay, we have like terms on opposite sides of the equal sign, so before we do anything else, we now must get these terms over to the same side of the equation. Okay, and I have two options. Once again, I can bring my negative 4x over to the right-hand side, or I can bring my negative 2x over to the left-hand side. Why don't we bring the negative 2x over to the left-hand side, which means I have to eliminate the negative 2x on the right side of the equation. Well, what's the opposite of subtracting 2x? Well, that would be adding 2x, right? And if I add 2x on the right side, I have to also add 2x on the left side. So on the right side, negative 2x and positive 2x cancel out, right? I'm left with simply 12 equals, on the left-hand side, what is negative 4x plus 2x? Well, that's negative 2x, and I'll bring down my plus 4. So I now have the multi-step equation, negative 2x plus 4 equals 12. My next step will be to subtract 4 from each side, right? Because I want to eliminate this positive 4. Plus 4 and minus 4 is 0. I'm left with negative 2x equals, what is 12 minus 4? That's 8. And then lastly, I will divide by negative 2 on each side to isolate x. Negative 2 divided by negative 2 simply leaves me with 1x. And on the right-hand side, 8 divided by negative 2 is negative 4. So my solution is x equals negative 4.